All right. Welcome, everybody. Let me share the screen. All right, that's awesome. Welcome, everybody. My name is Hossein Seattle. Welcome to Web Development, the graduate version, CS5610. We will be meeting for the next 14 weeks to talk everything about web development. Potentially, tentatively we'll be meeting on Mondays and Wednesdays at 2 o'clock. I'm not quite sure if that works for everyone. I will post a couple of polls, see if there are better times and days that is better for the majority. You're not required to be here. You can consume this content asynchronously. So all the lectures will be recorded and available on Zoom or YouTube. If you don't see the recordings immediately in your Zoom account from Canvas, I will be also making this available on YouTube on a particular channel, on a personal channel. So yeah, you should have received invitations to join Piazza, and that should be our main mechanism by which we should communicate. So feel free to ask questions there about anything that has to do with the assignment, or the course in general, any troubles that you might be having, compiling things, deploying, debugging. The TAs are going to be looking at this very attentively and try to get back to you as soon as possible. If you do have something more personal, then sure, you can use my personal email, or you can call me. I usually share my phone, and you can just text me. And I'm usually very available. If we need additional time offline, and you can just text me, and you can jump on a Zoom and go with that. I'm planning on doing office hours early in the morning, maybe around 8 and 9 every day. So that's an opportunity for you to come with questions, or where we can do a more one-on-one. So yeah, come to that. Obviously, you should all have access to Canvas, and where you can find the assignments, the quizzes, and all the slides that we'll be using for the course. Let's see.
Hey, Professor. Sorry to interrupt. I think there is an issue with your mic. I believe a lot of students are not able to hear you properly.
Okay. All right. Let me check. Let me check. Let's see. Audio. Hello. Test mic. Hello. Can you hear me? Hello.
Yeah, I can hear you, but the voice is still patchy.
Okay. All right. Let me try. Let me get them right back. Just a second.
Sure.
Let's see if this is better. Hello? Hi, can you hear me a little better now?
Yeah, that's much better. Thank you.
All right, awesome. Thank you. Also, how's the video? I think I have a pretty strong internet connection, so there shouldn't be any. Fail to detect your speakers. Please. Hello. everybody hear me?
Yes, I can hear you.
Okay, perfect. Okay, yeah, so let's take a look at the syllabus real quick. Let me put this down here so it's out of the way. Yeah, so we are in fall 2022. There are several sections in CS5610 as well as a couple as in 4550 that is using some of the same material that they'll be sharing. So there are some references here that go for 5610 and a couple things that are true for folks in 4550, and they should be noted in the syllabus. But in general, we'll be meeting again tentatively Mondays and Wednesdays from 2 to 3:30. Again, you're not required to come to the live sessions, although I strongly suggest that you do come. Everything's better live. Let's see, a couple of the TAs are still filling up some of this. The agenda, again, we're going to be together for the next 14 weeks. It splits up into two halves. The first half of the semester, the second half of the semester. The first half of the semester focuses mostly on interface part of the application. We will be using React.js as the framework to make front-end user interfaces. Whereas in the second half of the semester, we're going to be focusing mostly on the back end, right, on the middle tier of the database, creating our own servers, creating our databases where we can store content dynamically for long term. And there will be about a quiz almost every week, starting from week number 3. So starting on week 3, we'll start having about a quiz every week, right? But not quite. There might be a couple of weeks that we don't, especially when we have the first exam and the last exam. Also, assignments, definitely there's going to be about one assignment per week starting this week. But there's plenty of time for you to get started and get it going. The first assignment, even though it goes today, it won't be due for till the 18th. So you should have plenty of time to complete. And the assignments follow the content, right? The intent of the assignments is to give you a chance to practice some of the basic stuff that is specific to that particular week, but then apply that what you just learned about that particular topic to actually build something, right? So, for instance, in the first week, going to be learning about HTML and how to style things and look things pretty. And so there's a lab section of each assignment, and then which it contains generic exercises just to learn about some of the principles and some of the techniques. But then the second half of the assignment asks you to build something with it, right? And that something is we're going to be building Twitter with a Twitter spelled Tuiter, which is heavily inspired by a popular social networks website application. So we're going to be building things that are inspired by the Twitter application, and each assignment will give you a chance to practice what you just learned, right, and how to use it to build something. And that Twitter application will spread over multiple assignments, right? So each week we're going to be adding to the application, right, just what we just learned, right? So yeah, so the first half is mostly user interface. We'll start off with some really basic stuff of HTML as the language where you describe the layout of the application and the main static content, and then CSS where we can style it and make it look pretty. So selecting fonts, background colors, foreground colors, and things laid out vertically, horizontally, and whatnot. We'll then learn about certain libraries that already implement some of the best practices for styling applications. So there's many libraries And this is just, we're going to have time just to look at two of them, right? Bootstrap and Font Awesome, although there's, again, there's plenty out there, and there that are, equally as applicable. But this particular course specifically just uses Bootstrap. Then we're going to start looking at how to dynamically generate content, right? So up to this point, the first 3 weeks, or week and a half, 3 weeks and a half, we're going to be focusing on implementing static content, right? And then starting on week 4, we'll start learning on how to implement dynamic content, right? How to react to user input, validation, add content, move things around. And for that, we're going to first introduce the programming language that we're going to be using throughout the semester, which is JavaScript, and how to represent data using JSON. Also, we'll learn a little bit about jQuery as a nice DOM manipulation language or library, a JavaScript library. But then we'll switch over to React.js, which is one of the more popular libraries, JavaScript libraries for implementing dynamic single-page applications. All right, so that will give us plenty of material for our first exam, which is right in the middle of the course. We'll do a review on the first half of the week, and then we'll do the exam the second half. So when we come back from the first exam, we'll focus on the middle tier on the back end of the application. The first week that we come back, we'll introduce how to implement your servers using Node.js. Again, here as well, there's many alternatives of server hosting a server application, of which we're going to be using Node.js, but certainly we use Java, Ruby, there's PHP, there's Python. There's plenty of other alternatives that you consider. We are going to be focusing on Node.js. We'll implement RESTful services, that structure the query and the response in a particular style. We'll talk about how to store data permanently in a non-relational database. We'll use Mongo. Again, here as well, there's a plethora of options that we can choose. MySQL, Oracle, SQL Server. We're going to be choosing Mongo as a non-relational database, which is very, very popular today. We'll also learn how to implement authentication, how to track people. Well, not track, identify folks and perhaps store information that is specific, that it's tied to their identity, right? So that folks can come back and log in with us, register, and have information that's specific to their identity. And then there's all throughout the semester, you're expected to work towards implementing a final project, right? So all the assignments, right, will work towards creating a specific project, which is Twitter, right? So all the assignments walk you through implementing Twitter, right? But then in parallel to that, you are expected to implement your own project, right, of your choice, right? You can choose whatever topic you want. You're encouraged to join with 2, 3, up to 4 other students to team together and work collaboratively to implement this other project. So you'll be working on the Twitter project, which is the assignments walk you through. But then there's a final project that is due at the 25th on the 25th week. That on the last day of class, that you have been working throughout the semester, right? So make sure not to leave this till the end. Already you should start looking who you might want to work with for entire semester, and also start looking at topics, right, that might interest you to work with these folks, right? So on the 21st week, we'll get started with a kind of bringing together all the different technologies that we've been describing throughout the semester. I want to bring it together to kind of show you an example of getting started with a project. By this time, I would expect you already have you've already decided. You might already have some prototype. You might have some static content already. You might already have some pages already built up.
that already navigate from a couple of places here and there, and you might already have identified the data that you want to use. Right, one of the requirements in the projects is that it needs to connect to some live data. Right, there's plenty of places out there that are sharing data for free. And so you are required to choose one and interact, build an application around that data source. So anyway, here I'm going to walk you through how would I go about implementing something. We'll create a little prototype. We'll have Thanksgiving break, and then when we come back from Thanksgiving, the last couple of week, the last week or so will be focused on implementing a project or answering your questions about the project, anything last minute things that you need help with and how to deploy it, especially because you're going to have the front end running on a server, you're going to have the middle tier running on another server, you're going to have the database running elsewhere, and they all have to communicate with one another, right? So that can get pretty hairy, right? All these communications going back and forth, and debugging remote servers is not trivial. So that last week or so is to help you out, resolving some of the last minute things. Anyway, so the last day of class, we will review for the second exam and in preparation for the second exam. And the project will be, you'll present the project not to me, you will demo the project to a TA, and they'll go through all the requirements and do a checklist, right? The requirements for this, that, and the other. So they'll go one after another. Can you demonstrate this? Can you demonstrate that you can do this? You can demonstrate that, right? And they'll just give you a final grade on the spot, right? So anyway, that's more or less what we are going to be doing. There are about 7 quizzes and 10 assignments. The quizzes are usually about 20-30 minutes long. The online classes, which is you, these quizzes will be all asynchronous, right? So we'll open up the quizzes for about 24 hours, and you have to complete the quiz within those 24 hours. And same thing with the exam one, first exam, the second exam. Those will be made available for 24 hours, and you're welcome to do them anytime you are available, that it's convenient for you. Okay. What else? So as I mentioned earlier, all these sessions are recorded, and they will be available either on Zoom and or on YouTube. Even though you're welcome to consume this content asynchronously, later time when it's more convenient for you, perhaps tonight, this evening. Please don't let it wait too long, right? The course is time sensitive, right? So there are dates that things are due. That I will be describing technologies that assume that you're familiar with the material that we've covered before. So there is there are things that have to flow in a particular sequence. That again, even though it's asynchronous, there are time-sensitive things that are due at a specific date. So please don't wait, just disappear for a couple of weeks, and then expect to be able to binge watch these videos and have a successful outcome, right? So please stay on top of the material. The course is very fast-paced, and so please be on top of this. And and don't wait. If you don't understand something, don't wait to ask for help. Because gaps in understanding, they accumulate over time, right? And then it makes it much harder later on to be able to fill those gaps, right? And then for you to still be productive. Okay. Again, very fast paced. Be on top of this. Ask for help. Okay. All right. Any questions so far?
I have a question.
Yes.
I put it in the chat, but a lot of companies seem to be moving towards TypeScript instead of JavaScript, and TypeScript works with React. So I was wondering if we are able to use TypeScript instead of JavaScript if we'd like.
Absolutely, yes, absolutely. You can use that TypeScript if you feel comfortable with that. Definitely, yeah, absolutely. Also, some folks were asking it was okay to, for instance, instead of using the databases that I'm suggesting, whether they might want to use maybe Firebase or use some other services. Again, for the projects, you are welcome to use any database, any service, or Next.js if you prefer to use that as well for the project. For the assignment, I would ask you to be within the confinements of what we ask, since that is graded very specifically. They have very specific rubrics, and definitely TypeScript. That's definitely doable. That's great. But for the project, you're pretty much on your own on what kind of technology you want to use. Okay. Oh, there's quite a few things in the chat for me. Django, sure. You can do the project on Django. Yep, awesome. Many companies. It's fine. I can hear you. Okay, all right. Okay, all right. All right, let's move on. I do want to make sure I cover the first assignment, since it is going out today, right? And it's due on the 18th. But I wanted to make sure that you have at least this weekend to work on it and complete that. So even before I look at some of the material, I do want to cover that to make sure we get that out of the way. So yeah, so this first assignment is available. If you make sure the student view syllabus, Piazza, Zoom lecture. Yeah, so right here, right? If you click on week 0, which is this week, and you click on A1 setup, should bring you right here. No, that's not it. Sorry. This one right here. Okay, and the intention of this assignment is to get you going with the environment that we're going to be using throughout the assignments. Okay. And what is the format of the quiz exams? Yeah, so all the quizzes and all the exams are going to be on Canvas. So you log into Canvas, you get started on the quiz. All quizzes will have a password, which I will share with you, at the beginning of when the quizzes are released and made available, and then you can get started. Usually the quiz will take you, I don't know, 20, 30 minutes, 40 minutes at most. They are timed. They are open book, so you're welcome to look at all the slides and whatnot. A lot of them are puzzles, so it's not like something you're going to find a question right away on the web for you to quickly quiz. It's usually something you think through, and we'll have some couple things you have to look at, very, very carefully to answer those questions. And most of them are multiple choice or fill in the blanks. There are no essays or things that anybody has to read, right? Just select from A, B, C, or D, or fill in the blank, and they will be pattern matched against the various options. Should the project be in groups or individual? You're welcome to do it individually, although I suggest that groups of 2 and 3 I think are ideal, but up to groups of 4 will be fine. Also, some folks have asked me if it's okay to team up with other folks in other sections, as long as you're within the 5610 sections. There's about 3 sections. That's fine. Anybody on Piazza, but please not with the folks in 4550. Only because the 5610 is a graduate course, and there are requirements that are specific to the graduate course that is not specific to 4550. Right? There are many more things that we ask you to do that we don't ask the undergrads to do. So it would muddle the rubrics quite a bit to mix and match graduates and undergraduates. So please, if you're within the graduate team, then yeah, you can join other folks. Individually, or again, you can do this individually. I would personally do something that with perhaps at least one person, maybe 3. I think 4 is already hard to manage. Bigger groups are harder to manage. I always have horror stories or folks complaining at the end of the semester that hey, we did all the work and so didn't contribute much. Now I'm worried about my grade, that I'm going to lose points, and it's because this XYZ didn't pull their weight. And I really don't want to have to deal with any of that drama. So if you don't feel that you're going to be successful with the group that you're that you're thinking of working with, only if you've worked with somebody before and you trust these other folks to not let you down at towards the end, then maybe a 4-person team might be fine. All right, so let's see. Yeah, so the first assignment is going to try and get you going with some setup of the technology stack that we're going to be using throughout the semester. Okay. First, it suggests a few IDEs. I'm going to be personally using IntelliJ, but certainly, code is very popular. Whether on your Windows or Mac, there's some very good IDEs that are specific to different operating systems. That you feel comfortable. That's great. And I particularly like code and IntelliJ because it allows you to step through, put breakpoints, and view the data as you're interacting with the application. Those are debugging is a big part of software development. So make sure that whatever you choose is going to give you a lot of support for debugging. Right. A lot of debugging that we're going to be doing, especially for the front end, will be on the browser anyway. So it doesn't really matter, which IDE you choose for that. We're going to be using Chrome for the most part for testing, running, and debugging our code. Yeah. So install an IDE. This is just a map that we're going to come back to on the somewhat of the setup that we're going to be using. Right, you're going to have a client machine, which is going to be probably your laptop, and where you're going to have a client application that is going to be your browser, or it could be your game, or it could be your phone that is running on your device, right? And that is sending a request, HTTP request, to this network that we refer to as the internet, and is hitting some other machine that's somewhere out there, which is a server that could be implemented with any number of middle tier technologies, right? It could be JBoss, Tomcat, Node, could be all sorts of servers out there, and typically these servers will have additional access to other resources, either static documents, images, text documents, HTML documents, movies, and whatnot. But also they might have also access to databases, right? Either MySQL, Oracle, Mongo, right? And then they'll respond. They'll generate a dynamic response back to the client that is either data or user interface, right? The user interface that needs to be rendered by the client, right? So we're going to be using this client server architecture. Notice the client and the server. It's an architecture that was invented in the 50s, 60s, and it's still going strong today. How to think about the structure or layout of who's talking to what. Okay. Anyway, we'll come back to this quite a bit throughout the semester. For the servers, we're going to be we're going to be using Node.js to implement our server. So Node.js is just a interpreter for JavaScript, just like maybe Java, the Java interpreter might be able to interpret Java, compile Java code, and you run things with Java, and then you provide a compiled Java class, or GNU, C, or whatnot, right? Or Python, or Perl, where you give it a script, and then you can run that script locally on your machine. So Node is the same thing. Node is an interpreter for JavaScript, right? That allows you to write a JavaScript script, right? And then Node will run it for you, right? And then give you the output, right? So the latest version is 18, right? And that's what I have installed on my machine. I encourage you to download the latest and install it, right? I already have it, so I'm not going to install it. I'll cancel this. So I already have it installed. Oops. So once you install that and you have it locally on your machine, you can start. We could do a couple things, right? And one of the things that Node does is that it installs a few executables. One is the Node executable, right? Literally Node, and which takes in as an argument, as a parameter, a script, right? And then allows you to run that script. Okay. And another thing that it allows you to do is install other things, install other libraries, right? And in particular, we're going to be installing a library, right, that allows us to create user interfaces, right? And so we're going to be using one of several Node executables. Node provides you with a Node executable, npm. NPX has several executables, right? But those three are the ones I'm going to be using over and over again throughout the semester. Node to run a script, npm, which stands for Node Package Manager, npm, allows you to install other packages, basically libraries. Allows you to download libraries and install them locally on your machine. Very much like your .NET allows you to install libraries for C# or Python, right? Allows you to download gems and allows you to install things that are specific to that language, and so or Java allows you to download things from using a POM file, using Maven, right? So each language, every language is not very interesting all by itself, right? Every language has very quirks here and there of the syntax and whatnot, but all by itself, a language is not very interesting. Usually interesting part happens in the libraries that have become popular around that community, around that particular language. Yes, so Node has a very active community, and they all share their libraries in this repository. It's a famous repository. It's called the npm repository for Node Package Manager. And here you have all the most popular libraries. Notice that React is one of the more popular libraries that folks are installing all the time. React and React DOM that allows you to build the front end applications, right? And then you notice that Express is also very, very popular as well. And it's a library for implementing the middle tier, right? Creating servers, right, that listen to incoming requests and generating responses. So tons and tons of libraries. Vue is becoming very, very popular as well. It's an alternative front end library. Angular is also very popular. Well, it used to be very, very popular, 5 years ago, and then it just tanked. And React.js has kind of replaced it as a more popular library. Same thing with Vue. Vue is becoming increasingly more and more popular as well. But React.js is still one of the leading libraries, so we're going to stick to React.js. Anyway, I've already installed Node, so I have npm, and I can with npm or npx. Npx is the same thing as npm, but it allows you to execute. That's the X, right? It allows you to execute a library, whereas npm allows you to download and install it locally. npx allows you to say, well, okay, not only download it, but not even necessarily install it. Just run it. Download it and run it right away, right? And do what it normally would do if you were running it after having to install it locally, right? So we're going to be using npx for creating our very first front-end application. Okay. So first, we're going to create a directory where we can do all our work. And I suggest doing your work at your home directory. I believe this command works on both Windows and Mac OS operating systems, right? They basically bring you to your home folder, right? So let's see, which I believe I already have that. So if I say cd, we do cd and then ellipsis, right? It takes you to my home directory, which is Jose.Annunziato. One word about folders, right? And I don't believe I need to say this, but please, all your folders, okay, make sure there are no spaces in your folder names, right? No spaces, okay? I know that certainly you can escape the spaces and whatnot, but they always sometimes they bite us, especially if you're going to be pushing this in a source control and it's going to different operating systems are going to interpret the spaces differently. So please, no spaces. All right. So anyway, from the home directory, I ask you to create a particular directory for this year, this academic year, and I believe I have this, CS 2022, and in there, create another directory called fall, which I have here, so cd fall, and in there a directory for your web dev. So let's go to web dev. I'm going to create and that's it, right? And I ask you to do all your work in there, right, for fall web dev. Do all your work in that directory, okay? Just so that we know where everything is. This will also help the TAs, with the expectations of how you have set up your environment, and it will help them know that we all set it up the same way. Okay. Again, you might have other courses, you might have other ways of organizing it, but please follow these instructions so that the TAs can help you more efficiently. I'm going to create a couple more directories because I have several courses that are doing the same thing. So I'm going to create a 5610 folder, which right now is empty, right? And so I'm going to do on my examples, all my work under this directory for the remainder of the semester. So anyway, in that directory, we're going to use the npx, having installed Node.js, which I think a lot of you have already, since I've heard quite a bit of chatter on Piazza that folks have already started working on the first assignment. That's awesome. That's great job. But if not, just follow along. So we're going to use npx to create a new React application called Twitter React Web App. If you go to npm and search for create React app, okay, there it is. Notice that it says that Facebook is the publisher. That it has a Git repository where it has the source code that implements create React app and some verbiage on what it is, how popular it is and whatnot. Okay, so weekly folks are installing it, running it 140,000 times. Right? So let's do that. Let's copy this. So npx create React app. Okay, so notice that right now it's empty, and if we paste that, it'll take a while. But basically, what it's doing is that it's creating this application under a folder of the same name, right? So it's going to create a folder called Twitter React Web App, oops, I meant to do something, sorry. What I meant to do is I'm going to actually not call it that. I'm going to add a few things here. I'm going to say, call it C5610. Call it 5610. And I'm also going to say that it's fall 22. Okay. So I'm just going to add this this at the end so that I can distinguish this from later on having to repeat the same, a few other things to the 4550 crowd. So I'll be able to distinguish from either one. All right, so let's do that. Okay, so there it goes. I'm not asking you to do it. Yours would be fine to just leave it like this: Twitter, React web app. Since this will be deployed in your own personal Git repository, in your own personal remote server on Netlify. But just a comment on the naming convention that I'm following here. So Twitter is the application we're going to be working throughout the semester, and it's a take on or is inspired by a popular social networking website that and it's going to have some themes around it. It's going to have some functionality that is similar to that. But this is a React web application. So this is capturing two things. It's saying what technology we're using to create this application, which is React, right? And it's also telling me what role does this application play in the overarching application, right? So this is only the front end, the web application front end. Okay. Later on, in the second half of the semester, we're going to create the server, okay, using Node.js, right? So we'll create the server, and it'll be called something like Twitter Node server or something. Yes. Again, the application is Twitter. We're going to be using Node as a server to implement a server, right? So that's what the naming convention that I'm following. Okay. Anyway, so looks like it's ready. So just ignore my first here. So if we go into the fall 2022 5610, in there, once you go in there, if you cd into that, we do npm start. So npm, again, npm is one of the executables that gets installed when you install Node.js. Again, you get Node, npm, and npx. So npm, it manages packages, right? Here, basically, we've created a package, right, of our own. Right? It's our own package. If we like it so much and we want to share it with our folks, you are welcome to publish it in npm. Anybody can publish their own libraries here in npm and make it available to the rest of the world, and folks will be able to install your code, right? Maybe embed it in their own libraries, right? And then build other more interesting things. But certainly you're welcome to do that. Anyway, so we have our own little package here, and we can start it, right? Before we do that, let me open it up with our favorite IDE. Let's say open. I'm going to navigate to let's see, 610. This one here. Open. Okay. So this project that we have created, it's a React.js project. Yes. Now React.js projects are, by definition, Node.js projects. Okay, Node.js projects. So all Node.js projects, right, have a package.json file. See that right here, package.json. This is similar. If this would be a Java project, you might find in there a pom.xml, right? That would allow you to install libraries, download libraries, whatnot. So package.json, right, is the equivalent in Java's pom.xml, right? It lists dependencies, right? For instance, notice that it has a name, the name of the project. It has dependencies. It says that it depends on these other libraries: the React library, the React DOM library, the React scripts library, and so on and so forth. Okay. So that's how we know that this is a node project. It's a little server that is going to host our web application that we're going to be working for the first 6 weeks, 5, 6, 7 weeks. Right? So we're going to be spending time, the next 6 weeks in this project, understanding how it works, right? And we're going to be reviewing it and becoming familiar with it ad nauseum, right? So if you don't follow along exactly right now today, don't worry, right? You'll become extremely familiar how this project is built. I'm just giving you some background. This is a node project. Now, a node project can be anything. We can do anything we want. Specifically, this is a node project that specifically implements a React.js web application. Okay, Node.js, just like any Java project or any Python project, they don't necessarily have to do anything with web, right? It could be a Java project that generates a little, widget that runs on your desktop, right? It has nothing to do with web. Same thing with Python, right? If you build something that does any artificial intelligence, it has nothing to do with web. So just like Python and Java are general purpose languages, Node.js and JavaScript are also general purpose languages, right? But specifically, this specific Node.js project implements a web application project using the React library, right? Very much like Java might use, UI widgets, right, to implement a nice user interface, right? Or it might use, Web 3D or Java 3D to implement, a 3D model or something, right? So this is specifically implementing a web application. And notice also that in here it defines several scripts. See that one of the scripts is start. Okay, so these scripts, these commands can be executed using npm. It's an npm space start. Okay, npm start will run this React script start, which what we'll do is that it will start a node server, a node HTTP server, and it will host the current web application. Okay, so let's do that and do npm start. So it'll start a little tiny Node.js application server, and it will execute the landing page of our web application, which is this rotating image at some point. There it is. Okay, so this is the boilerplate sample application where we can get started and build all sorts of user interfaces. Okay. And is where we're going to be spending the next, 6 weeks, right? Just working and learning how to implement things. Okay, so this code here starts off this here. If you go to source, most of our time we're going to be spending on source. Actually, no, the first couple of weeks we're going to be spending instead of public. The first 3 weeks or 2 weeks. And then the following 3 weeks after that, we're going to be spending under source directory. Public contains all the things that are static, right? Like images or text or hard-coded HTML documents. We're going to be learning about HTML starting next week. And then where a source contains everything that is dynamic, right? So which contains, all sorts of JavaScript or TypeScript. And the entry point of this whole thing, right, which there's a lot of magic happening, and we're going to dispel all this magic, right? We're going to be learning about all the magic that's happening here, is that it all starts in this index here, right? In the web world, index files have a very special role, right? It's kind of like the default document that gets rendered, right? You don't specify, right? So this is like the entry point of the application, right? So this is the entry point. Notice that it has some opening tags. We'll learn about tags next week. But the entry point is right here, this div right here, this div. This div, notice that it's empty. There's nothing in it. It has an opening div, and then it has a matching closing div, and it's empty. He says, well, everything that we see on the screen here is what you see right now is all inside of this div here, this root, ID root. And you say, well, how could that be? Well, it turns out that there's a dynamic part of the application which takes over this static content, right, and injects dynamically, programmatically injects the content inside of that otherwise empty content, right? So the entry point of the dynamic world lives in the source, right, under here under index.js. Notice that it's JS, right, where it's just JavaScript, right? So you'll see here some executable code, right? There's several import statements, right? There's some function calls, right? There's a rendering, right? And then in here, there's things that look like HTML again, right? Which is kind of weird. Oops. Oh, wait a minute. There we go. So in our HTML here, usually you have pointy brackets everywhere, right? We'll learn about HTML starting next week. I guess we already started learning about it. So here, this JavaScript seems to have a kind of mixture, right, of executable code, right, and a mixture of HTML, and that's a new syntax called JSX, which is kind of like a mixture of JavaScript and XML that looks to kind of erase the wall between these two worlds, right, of the executable code and the rendering code, right, of what gets rendered. So HTML is strict. It used to be that JavaScript was strictly only for computation. JSX, right, seeks to remove the barrier, between these two worlds, right? A little bit counterintuitive from those that come from model view controller, where you have you have a very well-defined view, a very well-defined model, or very well-defined controller, and these two worlds don't mix and match, right? Let's see, there's a question in the chat. Yes. I'm just going to disable that for now. It's complaining that it's not meeting my my linting. Yeah, I'm going to disable that. My syntax, whether it might not like my quotes, or it might not like my spaces or whatnot. Let's not deal with that right now. So anyway, so these two worlds merge, right? This HTML static content and this dynamic part, they marry right here. This is the marriage between those two worlds, right? What you see here first is there's document.getElement by ID, this root. See this root right here? It's this root right here. See that? So it's grabbing, saying, hey, grab that element, right, that is already rendered on the browser, grab it, okay, and in that root, render the following, right? Inject this content, okay? And what is that content? Let's not talk about the strict mode just now. The content is right here, this app.js. See that right here, this app. And if we go in this app.js, it's basically this app.js right here, right? Notice that it doesn't have the .js. That's a syntax sugar that you don't need to include the extension. It's implied that these are all JavaScript. So if we go in there, right, it's this app.js right here. That look what this contains. It's basically a function that returns something. See that? It's a function that returns something. That's all it does, right? And what does it return? Well, it returns something that looks like HTML. Okay, it's evaluating to content that is going to be injected, right, by render. Is going to be injected. What is it injecting? Look at this. Edit code source, right, and save to reload. Look at that. There it is. See that? That content is right here. So this here is the content that is being rendered by this screen right here, right? So it has an image. There's the image, right? There's this image, which is a spinning image. there's this paragraph, and then there's a hyperlink here. There's a link that if you click it, is going to go to React.js.org. There is this link. So if you click on it, notice that it navigates to the React page, so you can learn more about React.js. See that? So there you go. So we have our first application, and one thing that the project is configured to so that you can edit the front end and the code, and it automatically recompiles and it redeploys and it reruns immediately. So for instance, if I have this here on the right and I have this on the left, right, I can edit the content. So I can say, for instance, I can remove that, right, and save. When I save, notice that immediately it's removed from the content, right? So if I instead say, welcome to web development, fall 2022. I notice that it changes, right? And if I change this as to be an heading 1, so to be bigger, it re-renders and it deploys locally. All this is running locally on our local machine. Okay, and in the terminal. Oh, well, actually, no, we started it from here, right? We started from the command line over here. To stop it, I can say Control C. Control C will stop the server. We'll say yes. Okay, and now it's not running, right? So if I do refresh, notice that it will fail, right? The server is no longer running at localhost 3000. Okay, I can also run it from within my IDE. So for instance, I can say npm start, right, from the same directory. So this same directory, right, this is the same directory that we are here in our console, right? But I can run it also from inside my IDE. I can say npm start. Right, this will run again. We'll start a brand new window on the browser. Starting the development server, and there it is. Okay, the server, notice that it's listening at this URL. URL means a uniform resource locator, so it's a locator of things on the web, right? So, and usually it's split up into 2 parts, well, several parts, but one of the main parts is the name of the machine or the location on the internet, right? The internet is, the networks of networks. And we're saying localhost, meaning my local machine, and listening on a specific port 3000, right? Now 3000 is a very popular port that web developers that implement in React.js or Node.js like to use port 3000. You might have used other ports for other purposes in other courses. If you've done some Java, 8080 is a very common port. For those that work on Java, if you've done any work on Angular, right? There's a port 40,000 is also very popular. So depending on what you've been doing, certain ports are very popular for different things. So yeah, so we're going to be spending localhost 3000 for the next 5-7 weeks. Okay. All right, so the next part in the assignment we ask you is to make this available to the rest of the world, okay? Right, but once it's running locally on your machine, nobody else can see it, right? Only you can see it. And for developing, it's perfect, right? You develop, you do all your work here, all your testing, and once you're happy, right, boom, you deploy it and make it available to the rest of the world, okay? And to do that, we need to deploy it in a remote server, okay? That is publicly available for everybody, all right? And so let's do that. So the first part to do that is to put this in a source repository, right? Now, the project is already configured as a repository, I believe. Let's see. Its status. Okay, yeah, so we are a repository. Notice that it has a gitignore directory file. So gitignore is a, oops, sorry. Git ignore is a file that describes things that the source control should ignore, right? So for instance, node_modules is a very common folder in Node.js projects that contains all the libraries that the project had to download and install locally. So certainly we don't want that as part of our source control, right? Other things that we should not care for is this one, .idea. So this one is a folder that was created by the IDE that I'm using, right, which is IntelliJ. So this is an IntelliJ specific folder. I don't, unless we all be using IntelliJ, then it makes no sense to share this with anyone else. So I'm just going to add it here, right, to ignore. My source control should not care about this folder. So we should not be sharing this for anyone else. But if you look at my, I can now say git add dot. So git add dot means add all my content to the local repository. All right, and so we'll do that. Oops. I'll say repository. Someone else. Huh? Okay. Warning. Okay. Git status. Okay, I add it. Git, I'm going to commit. And I'm going to say, first commit. Okay, so first commit has been added. So now my source has been added to my local repository, which already was created, but I didn't have to create it. It was already set up for me when I created the project. When you said npx create React app, right? It created the repository for me locally on my machine. Now I have to push it into a public repository that is available on the web, right? So let's do that. We're going to be using GitHub, and we're going to be using our own personal GitHub repository. I'm discouraging you from using the university's GitHub, since it has a couple limitations. You can't invite others to as collaborators, things like that. Right? Also, you want to make this available publicly because this might be you might use this for job interviews. You might want to show this and share it with other folks. So I suggest you make this publicly available. Oops. So let's do that. I'm going to create on Git. Let's create a repository. Let's see if I have one open. Git. There we go. So I'm going to say create a new repository, and I'm going to use the same name as the repository that I created locally, and it's called Twitter React Web App blah 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 5610 fall 2022. I'm going to say use that name. It says that name is available. I'm going to say go ahead, create it. It's public, and here it's just giving me a sample set of commands to push my content to this repository. I don't have to follow everything perfectly, since let's see, some of these commands have already been executed. I've already initialized this. I don't need to do that again. I've already added my content. I already committed my first commit. Change the branch. Let's do that. And by default, the branch. So if you do git branch. By default, the name of the branch is master. So I'm going to change it to main. So now the branch is main. Perfect. And then we're going to add this repository that I just created, that it's under GitHub, and it's my name, and that's the name of the repository. And I'm going to add it as an origin. Right? This is the default repository to which we're going to be pushing content to. Okay. So notice that if I say git remote, notice that it's empty. There are no remotes, right? It's not, this local repository is not linked to any remote repositories. But if I add one, if I say add, right, and paste, if I say git remote now, it says that now I have a remote that is called origin. I can say, can you be a little more specific, verbose? It says, yeah, there's a repository called origin, which points to this remote GitHub repository. So anything that you're going to be pushing, any content is going to be deployed, right? It's going to be copied over to that remote repository. Also, when you do a pull, right, that's what I'm going to be grabbing content from that same repository, right? So now we're ready to push. We say push to. I'm going to push up to the origin repository, remote repository that I just created. I'm going to push the branch main, right? So my local main branch, I'm going to push it to the remote origin repository. Say paste. So this is going to be pushing to. Going to ask me to sign in on my browser. It depends how you have it set it up. I have it so that it asks me to log into my repository, which I already am logged into GitHub. So notice that it said that it was able to push the content. Now, if I refresh my GitHub, so if I refresh, notice that it will have all the source code that I had locally on my machine now has been copied over to the remote GitHub repository, right? So if I say, notice that it has the same content. See that has public, source, these two folders, public and source. Public and source are there. Notice that the node underscore modules directory is not there, right? Because it is included in the .getting. Right? We added .idea, right? So that we don't want that to be our source control. Everybody okay? All right. So this is this URL here at the top. That's part of one of the deliveries that we're asking you to deliver as part of the first assignment, right? We want you to provide this URL so that the TAs can have access and come and look at the source, your source code, right? And see if you're having any issues, right? They can take a look at your source code, see, how can they help you. All right, so once this has been set up, we can now deploy our local application to a remote server and then share it with the rest of the world. Notice that right now, our application is running on our local machine. We wanted to, we're so proud of what we've built here and that we want to share it with everyone else, right? So the first part was to push our content to Git, okay? So let's see. So what we're going to do is we are going to be using Netlify as our service, our remote server that is going to be hosting our content. Okay, the assignment asks you to create an account. Okay, we did the source control part, right, to make sure that your gitignore contains the right things, that you're going to have the name of the application, you're going to commit the content, right? You're going to add content, commit it, right? You're going to push it. Obviously, my commands have the names, my username in it. Obviously, don't use my username. Use your own username. And then, to deploy it to a remote server, we're going to be deploying to Netlify. Okay, so Netlify. So Netlify is a service that allows you to deploy your applications to a remote server so that you can share with the rest of the world. Okay, so this walks you to how to deploy an application using Netlify. First, you'll need to create an account, right? You need to log in, right? And once you log in, you'll be in a dashboard that looks similar to this. Okay, at first you won't have any applications deployed, right? And to deploy a new application, you can create a new site. You can say add new site, and you can start either from a template, right, or you can say import an existing project. And our project is in GitHub, right? So we're going to say, yeah, I've already put all the source code on GitHub. I want you to, copy that over and deploy it and run it locally on your machine, right? So I'm going to say GitHub. It'll ask you, if you're not logged into GitHub, it'll ask you to log into GitHub, authorize it. I've already authorized it. And now I can search for the repository, which I know is called this. This is the name of the repository. So that I can copy this, or I can start typing to Twitter, React, web app, blah, 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 blah. Let me type that. So Twitter, let's say Twitter. I think I have a few of them called that. Oh, here it is. Here's the one we just deployed, right? The one we just pushed. So I'm going to select that. It asks you, okay, which branch? I only have one branch. And this is the command that we're going to use to run and build this, compile everything together, and deploy it. Okay, so we're going to say deploy. I'm not going to change anything. You can leave it as is. I'm going to say deploy site. This is going to take maybe a couple minutes. And you see down below, it says, right, the builds that are running. See that? Right. And also, this is the name the generic name that is going to be using for the project, right? And this is going to be different for everybody, right? It's just a random name, which is a random two words followed by a random token. Okay. You can look at the building process, right? If you click on here, it'll take you to the logs, right? As it's building your project. One of the first things that it's going to do is that it's going to clone down, right? It's going to do a git clone. See that? It's cloning the repository to their own local services, and make sure that it's using the correct Node.js version. It's using the correct version of npm. It's building, right? It's running npm build. Okay, it's done. So it says site is live. If it would have run some difficulties, some errors, it would have displayed here what the errors were, and it looks like it's been successful. I should be able to click on the link. Let's see. And see site, blah, blah, blah. Site, oh, it says in progress. Okay, so it's still in progress. I thought it was done. Site overview. Refresh. Looks okay. It says that it's published. Okay, good. So now I should be able to just notice that this is the URL. That if I click on it, right, it takes me to the application now. The same exact application I had running locally. This is the application running locally. This is the application now running on Netlify. Okay, with the URL, right? The two silly words followed by a silly random ID, but netlify.com. But notice that it's the same exact content. See that? All right. So this URL is also part of your deliverable. Okay. The assignment asks you at the end, if you go down below, asks you that you have to provide two things, right? For a whopping 50 points, the repository, okay, and also for a whopping 50 points, the Netlify URL, okay. So I'm going to use these URLs. I'm just going to copy them. I'm going to provide them here so that you can follow along. So that's the URL, and that's my URL. Also for the GitHub repository, I'm just going to update this, and I'm going to update my assignment here so that you can follow along. I'm going to paste that. There we go. All right, so there you go. By the end of this assignment, you'll have those two things, right? This URL for the repository and this URL of the application running on a remote server. Okay, that makes sense? There you have it. That's the very first assignment. Right. Again, this should not take you more than an hour or two at most. Obviously, some folks will run into a couple of issues of logging in and syntax errors and whatnot. And so you have till the 18th, I think, I think that's next Sunday, not this Sunday, but the following Sunday, to resolve all those issues. But I would imagine that most everybody will be done by this weekend. All right. But again, the TAs and myself, I'm here to help you. If you encounter any issues, please let us know, and we'll step in and help you out. Okay. Any questions on what we just did? All right. Okay. All right, so we went over assignment 1. Let's take a look at some of the content here. Now, these 4 slides here: installing Node.js, creating a React app application, committing your source code, deploying to Netlify, basically document what we just went over. Okay, this one documents installing Node.js, going to Node.js, and downloading Node.js, seeing what version of Node.js it is. It even walks you to implementing a simple Node.js server, right? Not necessarily a React server, but just a plain Node.js server. And it just plays around with a hello world JavaScript application, creating a simple, a tiny little server, and then trying it out, right, in hitting that server. Okay. Then once you have Node.js installed, the next couple of slides walk you through getting started with React.js, right? In PX, create React app, web dev. We're using Twitter. Then starting the application, just perusing through the application using your IDE. It just walks through a little bit through the structure of the project and index.html, and then the root div that I just showed you, right? And then the index.js that I also showed you as well. Let's see, there's a question on the. Does the assignment allow us to experiment with things beyond the scope, or it needs to be to a team? As long as these 2 URLs, are not wacky, and points to an actually working React application, I'm fine with you playing around with the actual content. Later assignments walk you through what we want you to do specifically with the content that you're going to be putting in there. But hey, have at it. As long as it doesn't interfere with with the theme of the assignment, definitely we encourage you to explore. Yes. The only 2 things that we're asking for right now is this URL of a running React application, right? So it doesn't give you an error of 404 or something, right? And also, the actual content in this GitHub repository. Okay. Let's see. Also, just walks you through the committing of the repository and then deploying in Netlify. Right. All right. So we have about 12 minutes. I do want to get started on some of the theoretical part, some of the history of web development, a little bit of context of why we're even doing this, right? How we got to this point. Kind of like a overview of the entire universe and where are we in that little portion of our little universe. Okay, so let's talk about web development in general. So first of all, what is the internet, right? We're going to be using the internet as the framework, the underlying framework where we're going to be doing all our development. So where does it come from? So anyway, so you all know a little bit about the story, right? That basically, the internet is a world, global network of computers that are connected, and then networks that are connected within networks, huge networks all over the world, right? And so, but a little bit of history, and it started off in the early '60s when the DARPA was a military research institution that was kind of like thinking about how to survive World War III, right? They were kind of like analyzing how do we how do we beat the Germans, right, in World War II? And he says, well, we bombed the heck out of them, right? So, and well, what that meant was that we made it really, really hard for them to move around and communicate, right, and coordinate any of their efforts, right? And some of the questions that these folks were thinking, ahead was as well, how do we avoid that happening to us at some point? So, can we use the latest version of the tools? Yes, absolutely. Yes, absolutely. Yeah, and if you do find that certain things, if you're exploring using a new version of the tools, and you see that some of the slides might not exactly match what you see on these newer tools, please let me know. I'll go back and update them. Okay. Okay. So yeah. So anyway, so all throughout the 60s and 70s, all the way to the 80s, right? It was exclusively a military project that slowly began to open up to academic institutions, all universities all throughout the world. And not until the 90s was there any commercial understanding of what could you possibly do with this thing, right? So yeah, in the 90s, it became much more available. Now, right before it became commercially available, many institutions were exploring of what you could do with the internet, right? There was no World Wide Web yet. There's no web first, right? It was just the internet. And there was a lot of tools that allowed you to just grab data from one machine to another machine, just transfer data from machines, right? There were machines that, computers that were specifically dedicated to storing just data and content and files, and whereas there were other computers that were desktop or terminals that allow me to go fetch files on some other remote machine and bring it over to my local content. That content was probably binary or text that needed to be compiled, and so that it could actually be rendered on the screen, right? So it was very, very cumbersome, transferring and sharing data and amongst the multiple computers. So Tim Berners-Lee at CERN, who was a physicist at CERN, he says, well, how can we make it a little bit more convenient? And so he came up, all by himself, invented the World Wide Web. And he said, well, how can we make it easier, right, to go fetch things from a machine and kind of sort of automate a little bit of the process of compiling the content so that it's visible. And so he invented the server and the browser, right? These two technologies of being able to fetch the content, right? Download the content locally into some cache, compiling it, right? And then just rendering on the screen without having to, having to do 3, 4, 5 different steps, right? Before you could see the content. And also he standardized what the content was. In this particular case was HTML. He came up with the language of HTML. XML was becoming very popular. HTML was a flavor or a particular vocabulary of XML that made it very easy, with just plain ASCII text files, implement, very useful documents, right? And so in his particular case, he was interested in sharing research material with other colleagues. So a lot of the early versions of HTML was for implementing documents that were research papers, right? For abstracts and multiple sections and paragraphs and images and tables, right? And just lists, simple lists. So HTML had allowed you to format content so that it looked like a research paper. He also thought of ways of how to connect multiple documents, right? Where if you're familiar with research papers, usually at the end of research paper, you have kind of references to other research papers, right? Of saying my research is based on these other work that other researchers have published. You can go look at their document, right, and then come back and keep reading my content, right? So he wanted to simplify that mechanism, right? And so he invented the anchors or the links or hyperlinks, right? Or text that allowed you to interact with the text, so that if you clicked on it, something happened. And then in our case, it went out and fetched the content, brought it down below, downloaded it, and then re-render that content, and you could go back and forth between multiple documents. And this was a a very simple set of ideas that together, right, just revolutionized the entire industry, right? All by himself, he invented an entirely new industry that just exploded from there, right? So it just lowered the bar for many other folks to say, I can create content, right, and link it together and make some compelling websites. Are there any books, resources? Actually, yeah. I actually have a book on this. I will be sharing later. I'll update it and make it provide a link on Canvas. So just a couple of milestones. The internet was worked in the 60s, and then with some of the theoretical part of this and how to lay out and what are the different roles of the different machines that are connected to this internet, right? A prominent architecture of the different roles of these machines, of these computers, was a client server, right? That if you could easily organize what each computer was doing, it was either being a client or being a server, right? It was either a bucket of files and data and that was serving multiple clients, right? That were usually, the servers were very, very powerful, that could have multiple clients connect to it at the same time. Usually these were huge machines in refrigerated rooms, right? And very, very monolithic, very powerful. Whereas clients were more, very lean, very not very, very powerful, but perhaps it just had the keyboard and screen. That's it, right? And then clients would connect to a server, download things. Not very dissimilar to what we have today, right? We have these servers running remotely, either Google or AWS or Netlify, whatnot, right? And then our clients are basically our browsers, right? Browsers are like a terminal that goes and fetches content and then just renders it for us, right? Then in the 80s, there was a huge explosion of personal computers where now folks could afford their own personal machines running on their desktops, right? So now they were becoming more powerful. You could do more things. So in the 90s, there was this revolution of the World Wide Web, people having browsers installed on their machines and being able to visit all these different websites. But not until the 2000s, right? People recognized all this disparate technologies, right, as a framework that you could build applications on top of, right? So in the 2000s, there's a revolution on the web applications, or the web as an application framework that you can build on top of that. In the 2010s, there's an explosion of interest in mobile computing, right, where instead of having desktop machines, we carry with us a powerful computer in our pockets, right? And who knows where we will be in the 2020s? Neuralink connected to Starlink, right? Connected to the Tesla bot, right? Who knows? Who knows where we're going, right? So things really start get going interesting in the 90s, right? So let's see what's happening during the 90s, right? At the very early on, when the World Wide Web just came out, and personal computers were becoming very, very popular. The Macintosh, right? The earlier Windows machines, right? Folks start and people start thinking, what can we do with all this World Wide Web, right? Everything was static, right? It was all static HTML documents, all static content. So how do we make it more interesting? And people are saying, well, what if instead of asking for a static HTML document, you actually run a script, right? The URL is referencing some script that executes and dynamically can compute what the content might be, right, on the fly, right, instead of being static HTML documents, right? So that idea just exploded, right? The first couple of examples were the CGI or Common Gateway Interface that was implemented using Perl or C++. Then it became extremely popular in the PHP world, right? Java too was just starting before the turn of the century. .NET jumped on this, Ruby, Django, right? And today, Node.js, using these are different languages, right? JavaScript, which had a lot of success on the browser side, it now starts having success also on the server side. Now, simultaneously, in tandem, in parallel, so that's on the server. In parallel, on the client side, on the browser side, we also see a lot of things happening, right? Netscape, one of the early ones, pioneers on browsers. They start thinking about, well, how can we make this dynamic also on the front side, right, on the browser side? While that's going on, Adobe is also doing a lot of experimentation using Flash as a means of implementing a dynamic content. So I'm sure, well, I don't know how old you are, right? But there was there was a lot of time there that everything, there was tons of Adobe Flash content out there for implementing dynamic content, movies and games and all sorts of real. Again, my kids played a lot of Flash games. But the intent was, how can we generate dynamic content on the client side, on the browser side, right? And so there was a lot of activity there. Dojo, jQuery, Knockout, Angular, right? And Google comes out with Angular in 2010. It's a huge hit. People love it. But there were still more additional, tools out there. But not until Angular 2 came out that Google made a huge blunder that folks kind of pulled back interest away from Angular. That it opened up the possibility for other folks or competing frameworks to succeed. So in that case, in particular, Facebook's React.js became extremely popular in 2013, and it has stayed there quite a bit. 2014, Vue.js has also become very popular. But the architecture is, right, you have this client running JavaScript or running React or Angular, Vue.js, or even any gaming library running on your phone or your desktop, right? That connects to a server that is hosting some executables there, either implemented with JS or Java or .NET, whatnot, right? That it's then connecting to some database in the middle tier. So there's two main ways that rendering happens. Up until the 2010, maybe a little early 2005, the most common way of generating dynamic content applications that interacted, right? We don't really care about static content. We really care about dynamic content. Was that Alice would go to a browser ask for a dynamic content. The content would request would go to the server. The server would execute an executable written in a particular language, ASP, JSP, PHP, Python, right, Java, JavaScript, right? It would execute the content, right, and then it would spit out a static content, right, that was dynamically generated. But as far as the browser is concerned, this is static content, right? And it renders it, and as the user interacts with the browser, it gets recomputed, and then the next one goes back, and then the Alice sees dynamic content, right? Because as she clicks, right, new things are being rendered or not, right? Now, the newer way of doing this, which has become much more popular today, and where we're going to be focusing most of our efforts this semester, is to instead, Alice requests some content. The browser goes and fetches some templates and some JavaScript code from the server, but then nothing executes on the server, right? The server, returns static HTML, static JavaScript, which then the browser executes on the browser using JavaScript, right? So it generates the content on the browser as opposed to on the server dynamically. Now, it might be that the browser might need extra data, right, to fill in the blanks. So it might go back to the server for an additional request saying, hey, I have the layout, but I don't have the data to put in there. So it might go back to the server asking for data. It would fill in the content, build the content, and then display the content dynamically to Alice, right? So this is where we're going to be focusing most of our effort throughout the semester. This is referred to as a single page application, right? And most modern applications that you visit today, including this slide, right? This Google's presentation is an example of a single page application, right? Notice that as I move between slides, it's very, very smooth, right? Everything's nice and tight, right? As opposed to this implementation would be that it would recompute the whole screen, and you would kind of see like flickering, right? And it would be a little bit jarring on how this would be implemented. It would be still dynamic, right? But the experience would not be as. Anyway, we ran out of time today. Please take a look at all those slides for this week. Work on the assignment over the weekend, and we'll be meeting again on Monday. Again, same time. If you did not watch this live, if you're not watch it but you're not here, please take a look at that the material, and do not let it wait too long before you consume this content. Okay. All right. Let's see, any last minute questions for our group projects? Do we need to discuss? Yeah, for the project, we'll talk about the project a little later. But in general, if you feel that you're within the boundaries and requirements that are listed in the requirements document, you don't need to run it by us, right? If you can answer and demonstrate that you have accomplished all those requirements, there's no need to run it by us. The only thing I would ask you is to please keep it PG-13, right? That's all. That's the only thing I would ask you. Will it be released at a certain time or date, or is it possible to work more than a week? Yeah. So I would discourage you from going way ahead, since I might change some of the assignments, and you might start working on things that are changing, or might change a few things depending on feedback that I might get from the students. So I tend not to encourage folks to go ahead. Anyway, thank you, everyone. I'll make this available for everyone in a little bit later. All right. All right. Good night.